in trigonometry, hello students, how are you? In trigonometry, we take this sine and cosine rule. In the sine and cosine rule, the triangle ABC, the important factor of the sine rule and cosine rule is that angle A, opposite side is represented by small a. This small a is the length of the side. This angle B is also the opposite is here B, and therefore this is your side B. And angle C opposite side is small c. So by sine rule, this is sine A upon A, sine B upon B, and sine C upon C. So A upon sine A, B upon sine B is equal to C upon sine C. We can write this thing. This particular sine A upon A, this first formula is used generally when we find the angles, and this second formula is used when we are interested to find the sides. What's about the cosine rule? The cosine rule is cos A is equal to B square plus C square minus A square upon 2BC. Cos B is equal to A square plus C square minus B square upon 2AC. Cos C is equal to A square plus B square minus C square upon 2AB. Here, how can we remember all these three relations? This is angle A. So side is in the negative form, minus A square. And the multiplication of these two sides, B and C, is 2BC. Similarly with the cos B. This cos B is the angle is B, then the side is minus B square. And this C square plus A square is 2AC. Similarly with the cos C, the side C is minus C square and the other two sides square, and upon this is the 2AB, multiplication of the two sides. So this is the sine and cosine rule. Now in the first example, if A is equal to 2, B is equal to 2 root 3 and A is equal to 30 degree. So find the angle of B. We use the sine rule because the two sides and one angle is given, and therefore we generally use at that time the sine rule. So by sine rule, sine A upon A, sine B upon B, sine C upon C, because we are interested to find the value of the angle. So we just take the two angles only, not necessarily the third angle. The sine A upon A is equal to sine B upon B. Sine A value is given 30 degree, and this A is equal to 2, and sine B is equal to upon 2 root 3. So 1 upon 2 into 2 is equal to sine B upon 2 root 3. So this cross multiplication 2 root 3 upon 2 into 2 is equal to sine B. This 2 and this 2 is cancelled, and it remains root 3 by 2 is equal to sine B. So this root 3 upon 2 is the standard value, and it is represented by 60 degree. So sine 60 degree and sine B. So naturally B is equal to 60 degree, but this 60 degree may be written in the radian form, that is pi by 3. So B is equal to pi by 3. In the example 2, in the triangle ABC, A is equal to 9, B is equal to 8, C is equal to 4. Then prove that cos B minus 2 cos C is equal to minus 4 by 3. First, we just find the value of cos B and then cos C. So this cos B is equal to, as we know that is equal to A square plus C square minus B square upon 2AC. The value of A is equal to 9 square plus C is 4 square minus 8 square upon this 2 into 9 into 4, and therefore that is equal to 81 plus 16 minus of 64 upon this is 72, and therefore that is 197 minus 64 upon 72, and therefore it is written 33 by 72. This 33 by 72 can be written as 11 upon 24. This is the value of cos B. I used this cos B value in the expression after some time. This is now cos C. Cos C is equal to A square plus B square minus C square upon 2AB. Here A is equal to 9 square plus 8 square minus 4 square upon 2 into 9 into 8, and therefore it is written as 81 plus 64 minus 16 is equal to 144. This is equal to 145 minus 16 upon 144. That is 129 upon this 144. Now I just put the values of cos B and cos C in this expression, the left hand side of this expression which I want to prove. Minus 2 cos C. The value of cos B is 11 by 24, and this is 129 by 144, and therefore we will write here 11 upon 24 minus, this can be divided by 3 or maybe any other quantity, so that is cos B minus 2 cos C. This cos B is equal to 11 by 24 minus 2. This is 129 upon 144. So that is 129 by 72. This 72 is my LCM, and that is 33 minus 129. That is minus 96 upon 72. Now I am dividing by 12, and that is minus 8 by 6, and again divide by 2. That is minus 4 by 3, and this is RHS. So this is the value of RHS, and this is the complete of our question. In the example 3, if any triangle, the ratio of the angle be 1:2:3, then prove that the ratio of the corresponding side will be 1:3:2. Here the side sum is 6. 1 plus 2 plus 3 is 6, and the sum of the three angles is equal to 180 degrees. With the help of this, we can find the angle A, angle B, and angle C. Suppose there is angle A is equal to 1 by 6 into 180 degree is 30 degree. Similarly, this angle B is equal to 1 by 6 or 2 by 6 into 1 by 80, that is equal to 60 degree. Angle C is equal to 3 by 6 is 180 degree is 90 degree. Now when we find this ratio, then we can say this is equal to sine A ratio sine B ratio sine C. Sine A value is 30 degree. Sine B value is 60 degree. Sine C value is 90 degree. So this sine A is 1 by 2. 60 is root 3 by 2, and 90 is 1. So the required ratio is obviously 1:3:2, which we want to prove. Now these ratios are 1:3:2. That's the requirement of this question. So now we solve 3 examples of the sine rule and cosine rule. Now in the next video we discuss about trigonometric equations, and with the help of these trigonometric equations how can we find the values of the angle. Okay, goodbye.